In mathematics, the Steinberg triality groups of type 3D4 form a family of Steinberg twisted Chevalley groups. They are quasi-split forms of D4, depending on the cubic Galois extension of fields KL, and using the triality automorphism of the Dynkin diagram D4. Unfortunately, the notation for the group is not standardized, as some authors write it as 3D4 K, thinking of 3D4 as an algebraic group taking values in K, and some as 3D4 L, thinking of the group as a subgroup of D4 L, fixed by an outer automorphism of order 3. The group 3D4 is very similar to an orthogonal spin group in dimension 8. Over finite fields, these groups form one of the 18 infinite families of finite simple groups, and were introduced by Steinberg, 1959. They were independently discovered by Jacques Tits in Tits, 1958, and Tits, 1959. Construction. The simply connected split algebraic group of type D4 has a triality automorphism sigma of order 3, coming from an order 3 automorphism of its Dynkin diagram. If L is a field with an automorphism tau of order 3, then this induced an order 3 automorphism tau of the group D4 L. The group 3D4 L is the subgroup of D4 L of points fixed by sigma tau. It has three 8-dimensional representations over the field L, permuted by the outer automorphism tau of order 3. Over finite fields, the group 3D4 Q3 has order Q12, Q8 plus Q4 plus 1, Q6 minus 1, Q2 minus 1. For comparison, the split spin group D4 Q in dimension 8 has order Q12, Q8 minus 2, Q4 plus 1, Q6 minus 1, Q2 minus 1. And the quasi-split spin group 2D4 Q2 in dimension 8 has order Q12, Q8 minus 1, Q6 minus 1, Q2 minus 1. The group 3D4 Q3 is always simple. The Shaw multiplier is always trivial. The outer automorphism group is cyclic of order F, where Q3 equals Pf and P is prime. This group is also sometimes called 3D4 Q, D42 Q3, or a twisted Chevalley group. 3D4 23. The smallest member of this family of groups has several exceptional properties not shared by other members of the family. It has order 211,341,312 equals 212 34 72 13, an outer automorphism group of order 3. The automorphism group of 3D4 23 is a maximal subgroup of the Thompson sporadic group, and is also a subgroup of the compact Lie group of type F4 of dimension 52. In particular, it acts on the 26-dimensional representation of F4. In this representation it fixes a 26-dimensional lattice that is the unique 26-dimensional even lattice of determinant 3 with no norm 2 vectors. Studied by Gross and Elkies, 1996. The dual of this lattice has 819 pairs of vectors of norm 8/3. On which 3D4 23 acts as a rank 4 permutation group. The group 3D4 23 has 9 classes of maximal subgroups of structure 21 plus 8, L2, 8, fixing a point of the rank 4 permutation representation on 819 points. 211, 7 times S3, U3, 3. 2. S3 times L2, 8. 7 times L2, 7. 2. 31 plus 2.2 S4, 72. 2A4, 32. 2A4, 13. 4. See also List of finite simple groups. 2e6. Carter, Roger W. 1989. 1972. Simple groups of Lie type. Wiley Classics Library. New York. John Wiley & Sons. ISBN 978-0-471-50683-6. Mr. 0407163. Elkies. Noam D. Gross. Benedict H. 1996. The Exceptional Cone and the Leech Lattice. International Mathematics Research Notices. 14. 665-698. ISSN 1073-7928. Mr. 1411589. DOI 10.1155 S1073792896000426. Steinberg, Robert. 1959. Variations on a Theme of Chevalley. Pacific Journal of Mathematics. 9. 875-891. ISSN 0030-8730. Mr. 0109191. DOI 10.2140 PJM 1959.9.875. Steinberg, Robert. 1968. Lectures on Chevalley Groups. Yale University. New Haven. Con. Mr. 0466335. Archived from the original on 10 September 2012. Tits, Jacques. 1958. Les Formes réels des groupes de type E6. Séminaire Bourbaki. 10 EANNE Acuity. 1957 1958. Textes des conférences. Exposés 152 a 168. 2 ed. Corrigé A. Exposé 162. 15. Paris. Secrétariat Mathématique. Mr. 0106247. Tits, Jacques. 1959. Sur la triality et certains groupes qui sont déduisants. Inst. Hautes études sci. Publ. Math. 2. 13-60. Cube D. 2 cubed. At the Atlas of Finite Groups. Cube D. 3 cubed. At the Atlas of Finite Groups.